Imagine this scenario. It's December, you're sprinting toward a deadline, and your inbox pings.
Uh-huh.
The notification that comes in looks utterly, impeccably legitimate. It's an alert from Google.
Okay.
The sender is Norply application integration at google.com, and the subject line warns you that access has been granted to a critical Q4 financial review file.
Oof. That's a high urgency lure.
It looks perfect. It passes every single security filter your organization pays top dollar for. So you click the link.
Yeah.
I mean, urgency demands it.
Of course you do.
But in that one instant, every layer of defense, the DMRC checks, the SPF verification, the link scanners, all of them fail.
And not because the attacker was clever at spoofing.
Exactly. They fail because the attacker was literally sending the email from inside Google's massive trusted cloud infrastructure.
Yeah.
That terrifying inversion of trust is really the core of our deep dive today.
It is.
We've got sources detailing a really sophisticated high-volume phishing campaign uncovered by cybersecurity researchers back in December of 2025.
Yeah.
This campaign basically redefined credential harvesting. It moved way beyond the crude typos and shoddy graphics we're all trained to look for.
It's a whole new level.
It weaponized the inherent trust we all place in the world's largest cloud providers. So our mission today is clear. We're going to unpack exactly how these threat actors successfully abused a legitimate Google Cloud feature.
And a very specific one at that.
The application integration service, to send nearly 10,000 highly convincing phishing emails globally. It's a technical masterclass in deception.
And that operational shift, that's what makes this deep dive so essential. This isn't just another story about spotting a malicious email.
Yeah.
It's about a critical evolution in the entire threat landscape. Attackers are no longer trying to just look like Google.
They're making Google's own tools work for them.
Exactly. The problem we really need to dissect here is structural. How did nearly 10,000 emails manage to originate from a domain that security filters are, structurally mandated to trust?
Right. If your whole security perimeter relies on flagging anything that looks suspicious.
And the source is technically, genuinely legitimate, you're already way too late in the game. This campaign forced security analysts to discern malice not through technical verification, but through contextual behavior.
Okay, so let's unpack this. Before we even get into the consequences, we have to understand the specific mechanism. What exactly did the attackers turn against users, and why was that single feature so devastatingly effective as an initial bypass?
Yeah, and the technical details are crucial here because this wasn't a flaw in consumer Gmail or Google Workspace security.
Right, this is on the enterprise side.
The abuse was centered entirely on Google Cloud's application integration service. You should think of this service as the digital plumbing for enterprises.
Okay, like connecting different systems, automating workflows.
Exactly. It connects disparate systems, automates workflows, manages data flow. And within that plumbing, the specific component they exploited was the send email task.
Send email task.
Yeah.
That sounds so benign.
It is. It's designed to be. If an organization is using Google Cloud to, say, automatically notify a finance team when a major transaction occurs,
or to alert the IT team when a server's utilization spikes.
Perfect example. They use the send email task. It's a legitimate, built-in capability designed for automated internal notifications.
And this is where the genius and the danger of this whole thing lies.
It is, because that send email task is part of the established, authorized Google Cloud environment. The email itself originated from a very specific, Google-owned, legitimate address.
Which was Norply application integration at google.com.
That's the one. And that is the golden ticket for phishing delivery.
That really does sound like a technical checkmate for traditional email security. So could you walk us through in a bit more detail why that specific address just sailed past all the standard defense systems we rely on? We hear about DMRC and SPF all the time.
Absolutely. So DMRC, that's domain-based message authentication, reporting, and conformance. And SPF, the sender policy framework.
They're the pillars of email security.
They're the pillars designed to combat email spoofing. They function like identity checks at the border. The SPF record defines which specific servers are authorized to send email on behalf of a domain, in this case, google.com.
So it's a list of approved servers.
It's an approved list.
Yeah.
And the DMRC record tells the recipient server what to do if an email fails that check. Usually, block it or send it to spam.
Right. So if a criminal sends an email claiming to be from Google, but they're using their own rogue server somewhere,
that server's IP address is not on Google's authorized SPF list. The email fails authentication. End of story.
But because the attackers here used Google Cloud's application integration service, they were using a server IP that was already on Google's approved SBF list, right?
Precisely. The email originated from the actual Google infrastructure. It's like a criminal gaining access to the official postal service truck.
That's a great analogy.
The mail inside might be malicious, but the stamp, the postmark, and the carrier vehicle are all 100% legitimate.
So the email passed DMRC and SPF verification with flying colors.
With flying colors. Because the sending server was, technically, the correct server for the google.com domain. It guaranteed delivery straight to the primary inbox, often bypassing any of the machine learning or behavioral analysis that looks for common spoofs.
Okay, now let's talk about the sheer scale of the operation, because this is where the logistics become just fascinating. Researchers documented this abuse over just a 14-day period in December of 2025.
A very short window.
And it resulted in 9,394 phishing emails targeting approximately 3,200 customers globally. Yet, Google's own documentation for this send email task imposes a technical limit.
A very important one.
A maximum of only 30 recipients per task.
30.
So managing that kind of volume, nearly 10,000 emails with a 30-recipient hard cap, that suggests an immense operational overhead. What does that tell us about the funding, the sophistication, and the scripting expertise of this threat actor?
It tells us two very important things. First, this was not a casual or opportunistic attack. This was the work of a highly organized, likely state-backed, or, a major criminal enterprise with substantial resources.
You'd have to be.
And second, to circumvent that 30-recipient limit and hit nearly 10,000 targets, the threat actors couldn't just rely on one integration. They had to operationalize this abuse at scale.
So they built a whole network of these things.
An extensive network. They would have needed to register, provision, and maintain a high number of Google Cloud accounts, we're talking potentially hundreds, and then script the automated creation and execution of hundreds of distinct application integration workflows.
So if you need to send just under 10,000 emails, and you can only do 30 at a time,
you need over 300 instances of this integration running. So you need the infrastructure to provision and manage those 300 instances, maybe even simultaneously.
Wow, that sounds like using a complex targeted precision rifle when they usually just use a crude shotgun like a spam cannon. Why go to all that trouble? Traditional spam campaigns can generate millions of emails for far less effort.
Because the effort guarantees the single most critical factor: delivery. A traditional spam campaign hits millions, sure, but maybe 99.9% of those are blocked by SPF, DMRC, reputation filters, or machine learning models.
So the yield is tiny.
Exactly. But if you spend that immense effort managing 300 integrations, you know with near certainty that the 9,394 emails you send will land in the primary inbox, completely trusted, for the 3,200 targeted executives and employees.
The rate of return on a highly trusted targeted attack like this is exponentially higher.
It's a different game. They're trading quantity for absolute quality and guaranteed deliverability.
So when you have that level of guaranteed access to the inbox, you can afford to be highly selective about your targets.
You can pick and choose.
The geographic reach was massive: US, Asia Pacific, Europe, Canada, Latin America. But let's focus on who they were trying to hook. What were the primary verticals affected here?
The targeting was deeply strategic. Checkpoints analysis highlighted 5 primary verticals: manufacturing, technology, financial services, professional services, and retail.
The big ones.
The big ones. And while they did cast a wider net, hitting sectors like education, media, and government, these 5 were the clear focus.
Why those 5?
Because they are the engine rooms of the global economy. Compromising a manufacturing firm gives you high-value intellectual property.
A financial institution gives you payment data, maybe insider trading opportunities.
Exactly. The potential payout is enormous.
But given that most organizations in these sectors invest heavily in premium layered security solutions, how did the attackers know that this internal workflow weakness, this reliance on automated alerts and shared documents, was their guaranteed best way in?
That's the critical insight. It shows a deep understanding of organizational psychology and workflow habits.
It's not just technical, it's behavioral.
Purely. These 5 sectors share a common characteristic: constant high-volume collaboration across dispersed teams, often relying entirely on Google Workspace or Microsoft 365 for file sharing, document comments, and approval workflows.
Okay, that makes sense.
Think about it. A financial services firm receives dozens of legitimate automated alerts every single day about shared client files or regulatory compliance reports.
And a manufacturing firm gets automated notifications about updated CAD files or supply chain logistics. There's this noise.
It's routine, so the why here is purely social engineering context. Google branded alerts are not anomalies in these environments, they are the norm.
So the probability of a successful outcome skyrockets.
It does, because users in these high-pressure, high-volume sectors are trained to trust these notifications implicitly and act quickly.
When an email referencing an urgent Q4 file arrives from the trusted google.com domain, the user's critical thinking capacity is dramatically reduced.
And that's precisely what the attacker relies on.
Okay, here's where the technical execution shifts from just delivery to active evasion. The attackers didn't rely on just one point of trust. They constructed this sophisticated multi-stage tripwire system
A whole chain.
designed to lower user suspicion across 3 different cloud platforms, all while ensuring security scanners would just hit a dead end.
It's really clever.
So first, the email itself. Since they already achieved maximum trust on delivery, the design was engineered for maximum familiarity.
They didn't need to get fancy.
No, they perfectly mimicked Google's notification style and structure familiar formatting, branding, and language. It's hard enough to question a legitimate sender. It's nearly impossible when the message itself looks perfectly formatted too.
And they chose their lures based on peak corporate urgency. They leveraged 2 highly sensitive communication types. One was mimicking voicemail alerts.
Right, which implies time sensitivity, personal communication that requires you to listen immediately.
Exactly. And the other, which was arguably more effective, was the claim that the recipient had been granted access to a shared file or document.
And they didn't just say a file.
No, they used highly specific, urgent-sounding files, like access to the mythical Q4 file.
Let's pause on that Q4 file for a moment. This attack peaked in December.
Right.
That's year-end stress time. Everyone in finance, sales, and management is scrambling to finalize budgets and reports.
Yeah.
How much does that simple context multiply the success rate?
Oh, exponentially. It capitalizes on the user's pre-existing cognitive load.
You're already stressed. You're already busy.
In December, if you receive an alert about a shared file, especially one labeled Q4 or year-end, your brain automatically assigns it high priority and very low suspicion.
You're predisposed to believe it's a necessary, expected workflow interruption.
The attackers didn't invent the urgency, they simply exploited the urgency the enterprise already creates for itself.
So the ultimate goal was just pure behavioral manipulation. Prompt recipients to click the embedded link and take immediate action.
Get them to bypass that 15-second window where a user might stop, think, and manually navigate to the file rather than clicking the embedded shortcut.
Now, let's follow the victim after they click, because this is where the attackers use Google's reputation as, like, a cloaking device.
Yeah.
They didn't direct the user straight to some suspicious domain. No, that would have been too obvious. Well, stage 1 commenced when the recipient clicked a link hosted on yet another trusted Google Cloud service, storage.cloud.google.com.
Which is the domain used for serving files and objects from Google Cloud Storage.
So if a security proxy or a scanner analyzes that initial URL, it registers a legitimate Google-owned domain.
And it confirms the veneer of trust that was started by the email sender. Everything looks good so far.
And that initial click immediately redirects the user to stage 2.
Right. This content was served from googleusercontent.com, another widely trusted Google domain used for user-generated content and hosting assets.
So far, so good from a security perspective.